Hello and welcome back to the Java and Minecraft modding tutorial. It's been a while. Today we're going to go over Booleans, if statements, and while loops specifically. So as you may notice, I've created two new classes. This one, Animal Classifier, is the one we're going to be coding in. And I've commented out all the previous code from Animal Project in order to, so that we can do different stuff with it. And I've made this new class called Walking Animal. Walking Animal functions just like Flying Animal, except instead of wingspan, it has num legs, and it has a method called walk, which just does the same thing as Flying Animal, except is walking instead of is flying, and it moves in the x direction by num legs. So yeah, it also has a slightly different toString method down here, which is with num legs. So an animal with 3 legs would say with 3 legs. Yeah. Now, by default, animals have 4 legs. I don't know if this is representative reality. It probably isn't, but yeah. So the animal classifier class is just used to classify animals in the sense that it won't solely classify animals, but one of the main things it'll do is just test conditions on animals. Now, conditions are a part of Java which are very important. Like programming, you can do basically nothing without using if statements or while loops or for loops, but for loops are not something that's directly relevant to conditions. So if we go to animal, we will see something called isDead. isDead is a Boolean. That means it can be only true or false. In code, it's stored as a number 0 or 1. A Boolean is a data type which is used for a lot of things, and it actually can be used in interesting ways. So if you look down here and you say public Boolean isDead, do you see this method here? Well, the isDead method will basically, it returns the value of the isDead Boolean. However, despite us setting isDead to just false over here, simply to, well, false, we don't have to hard code the value of a Boolean. We can actually use something called a condition instead. Now, first of all, we should probably check if an animal is dead somewhere. So when an animal is living, quote unquote, it can't be dead, right? If it says it's living over here, but if we set isDead to true and we call animal.live, it'll still say blank is living. So rather than having it just say that it's living, even if it's dead, we can use something called an if statement in order to check whether it's dead or not. If is dead, then do something. System.out.println name plus is dead. Now what this does, an if statement is a funny thing. So these curly brackets, they represent something called a scope. Everything within this code is a special area of code which will only run when this condition is true. Within these parentheses, you put a Boolean. So you're checking a Boolean. If the Boolean is true, then it'll do this. If the Boolean is not true, it'll skip this. So right now, if isDead is true, it'll do this. If isDead is not true, it won't do this. So just for perspective, and it'll behave a little bit weirdly at first. That's because we have forgotten the crucial part, but I will cover that after I show you how this works. So animal per, yes, per is the name. Okay, new animal, right? We just created a new animal. Now, why is this? Ah, forgot the name, I'm sorry. Okay, new animal, per. Okay, so now that we have per, we can do per.live, and per will just do live. Now we do per.kill, and then per.live. What is going to happen? Well, we will find out. All right, let's go. Now, just so you're aware, this button up here can run the project, but you can also go to run as after right-clicking the name of the driver class, which is the class of the main method. So you go to the class of the main method, you right-click run as, and you do one Java application. So now you see something funny. When we do the call the live method up here, it says per is living. And notice how if we go to the live method, it should say per is dead, right? However, and by default, an animal's status is dead is set to false. So initially, is dead is false, and therefore this block of code does not run. However, when we do per.kill, let's just look at what kill does. It sets is dead to true. So after per.kill, we call per.live again, and it runs this little block of code, is dead. So then it prints out per.is dead. But notice how it prints out per.is living right afterward. It prints out per.is living because we haven't made this line of code special. We haven't done, oh, if animal is living, run this line, these two lines of code. So now we can do this one of two ways. We can use something called the not operator. The not operator will check if the value of this Boolean is false. So if I go, if not is dead, then do this. And let me just format this correctly. So what this means is that if is dead is set to false, this block of code will run. So if not is dead, print out that this is living and age it. All right, so let me just close this console and run it once more. Now this time it says per.is living when we call per.live, because remember, the block of code that says is dead does not run. It will not run anything because the animal is not dead. However, when we kill the animal, it is dead. So when you go to per.live, well, it will not run this block, but it will run this block because this block checks whether the animal is dead. If the animal is dead, it runs this block. And since the animal is dead, this block evaluates to false. So it does not run this block because since this is false, it'll just skip all of this. So that's pretty cool. We can basically exclude parts of our program from running as well if a certain condition is not met. That condition is represented by a Boolean. A Boolean is just a true-false value. Now, this can be a bit boring, you know? Well, first of all, there's another way to do this rather than just writing, oh, if is dead, if not is dead. Because, like, it's going to get tiring writing out if is dead, if is not is dead. So what we can do instead is that else. Else basically is like, oh, if this statement evaluates to false, if we skip this block of code, then we run this block of code. Now, this block of code, basically this block of code will only run if this block of code does not run. Otherwise, this block of code will run and this block of code will be skipped. So if we go back here, we can see it runs in the exact same way. because all else does is basically the exact same thing as if not is dead. However, one thing to note is that an else automatically links up with the if statement that's right before it. So if I just write system.out.println hi right in between, the else will have an error. Why? Because there is no if statement right before it. So you have to put an else right after the if statement. Now, the else is all well and good, and if is dead is cool, right? You know, you can put a Boolean, you can check a Boolean. But the thing about Booleans is that hard coding true and false values doesn't really work. What we have to do is we have to make sure, we have to learn a way to put a condition into an if statement. Now, when an animal is living, it's aging up, right? Well, at some point, its age gets high enough that it dies. Unfortunately, it's true. There's only one animal I know of which can avoid this natural aging, and that's the immortal jellyfish. Fun fact, the immortal jellyfish quite literally sets its age back to 0 when it gets too old and becomes a baby again. Yeah, doesn't work with complex life forms like humans, but I think it's pretty cool. So anyway, since animals die eventually, we need to make it die. So what we'll do is, in this, we'll check whether the value of age, so age plus plus over here, increase the age by 1. We'll check whether the value of age is higher than a certain number. If it is higher than that certain number, then we will use it to kill the animal once it gets higher than that certain number. Okay, so if age, and here we use something called the greater than operator, exactly what it sounds like. It's the exact mathematical equivalent of the, well, familiar operator. If age greater than 50,000, I know that sounds like a lot, but like if you think about it, a program runs 1,000 times in a second. It runs a lot. Like the tasks the computer can do are really fast. So if we don't set it to 50,000, our creatures will only exist for maybe like they won't exist for very long. They'll only exist for a certain amount of time. Now, I mean, whether that's important or not is up to you. We can also set it to 50, we can set it to 50,000. It doesn't really matter. But anyway, 50,000 means we can have a lot of tasks be done in between, specifically like 50,000 tasks. So now we have a greater than sign, and you might have noticed that, wait, isn't an if statement only supposed to take Boolean values like true or false? Well, that's correct. But the funny thing about these operators like greater than or greater than or equal to, this is, by the way, the same thing as writing greater than or equal to sign. These operators, they represent Booleans. They're like special magical things that represent Booleans. You can write a Boolean variable, Boolean condition equals age is greater than or equal to 5,000. And this, the program will basically evaluate this condition. It'll figure out, is age greater than or equal to 5,000? If so, it'll return true. This condition will be true. Otherwise, it'll be false. So what we can do with the programs is, instead of just having a Boolean in the if statement, we can also write a condition in the if statement. Now, if age is greater than or equal to 5,000, we want the animal to kill. So just this dot kill. Now, voila, we have killed our animal. Yes, I mean, it's sad, but it happens. So I'm sorry. Anyway, we have now aged up the animal, and once the animal gets to a certain age, it will die. Yeah, it'll die. Okay. So now we can, instead of doing per dot, I'm gonna make kill print something so that we can identify it easier. So println name plus is now dead. Okay. Oh my God. Okay. So then now if we go down here, purge.live. Now instead of doing purge.kill, what if I just did purge.age 50,000 years? Well, now since purge starts at age 0, if we increase its age by 50,000 years, it'll be 50,000 years old. If it is 50,000 years old, it should die because greater than or equal to checks whether its age is greater than or equal to 50,000 years old. So now back here, if we call purge.live here, it should say that, well, first of all, it will run this code. It will evaluate this to false because purr is not dead yet. However, once it gets here, it'll say purr is living. It'll increase the age. It'll find out, hey, wait, age is greater than 50,000, and then it'll kill it. So let's run that. Purr is living. All right, that's over here, purr.live, because is dead is false. Purr has aged up to 50,001. So now because it has aged up to, oh yeah, right, because age plus plus occurs here, it's actually 1 year old. But anyway, 50,001. Purr has aged up to 50,001. So now its age is currently 50,001. So when it gets to the second live method, it'll check, is it dead? No, it's not dead. However, it'll then check, okay, since it's living, let's increase the age. Then it'll check, is age greater than 50,000? And since 50,001 is greater than or equal to 50,000, it will kill it. It'll die. So that's why purr is now dead. You know, if we include an extra purr.live statement over here, it'll say purr is dead because purr is dead at this point in the program. So now that we've gotten this far, let us go to animal classifier and let's make a simple Boolean method. This method will just check if an animal is a baby, and it will take an animal as its parameter. Now what it'll do is it'll check if the animal's age is less than 10. How about 10? If animal.getAge is less than 10, return true. All right then, that works, right? No. So the funny thing is, an if statement skips the code inside of it if its condition is false. So actually, the return statement must exist in a place where it can be run. If this code block is skipped, the method doesn't know what to return. It'll just be like, hold up, I don't know what I'm supposed to return in this method. And a method cannot just return nothing. That's not possible. So we have to actually add else, return false. Alternatively, we can just remove this entirely and it'll work fine because the return true automatically ends a method. Any statement which has return in it, even for a void method, will end the method. For a void method, you can't return a value. So for a void method, you just write return. But if you write return, it automatically ends the method, which means you don't need an else statement at all, because if this method runs, it won't actually go past the return statement. And if this doesn't run, it'll just run this return false down here. So yeah. Now, if we do animal.getAge is less than 10, animal's a baby, it should say that animal's a baby if we go over here, purr.live, and then we say system.out.println. All right, now we have to create a new animal classifier because after all, animal classifier is still an object. So now that we've created a new animal classifier, import, we can print out classifier.isBaby purr. And I need to save everything. If I go over here, it says that that per is a baby. Now, if I go over here and print out whether it's a baby, it should say it's not a baby, false. Now, let's just remove these two, no, let's just remove. Now, let's just look at this statement for a second. Animals can die. And if an animal is dead, can it really be called a baby? Like, I mean, not to be morbid here, but it feels a bit odd to call an animal, check whether an animal is a baby if it's dead. So let's do animal.isDead as a check. If the animal is dead, it should just return false because the animal is dead. Now, in order to check whether the animal is a baby, well, first of all, if the animal's dead, it'll just do this and it won't run anything else. So we don't have to worry about that. Now we can check whether the animal's baby. If animal.getAge is less than 10, return true. Otherwise, return false. So if animal.getAge is less than 10, this method will return true. And if both of these conditions evaluate to false, it'll return false. Now we can simplify this line of code here, right? Because if getAge is less than 10 is a condition, and when the condition is satisfied, it returns true, but otherwise it returns false, we can simplify this to just return animal.getAge is less than 10. After all, it's still returning a Boolean because a Boolean is a condition. So now that we have animal.getAge is less than 10, and we use isBaby, we can go over here and do system.out.println classifier.isBaby and we can remove this little aging statement over here in order to see how this works out. So then if we remove this statement about age, well, technically the animal won't be dead anymore, so we still have to kill the animal somewhere in between. So here you go, die animal, sorry. Okay, now if we check whether it's a baby, system.out.println classifier.isBaby per, it should return true up here because it'll still be a baby, but false down here because once it's dead, it's no longer considered a baby. So now it says false. And in fact, we can even say if classifier.isBaby per return, not return, system.out.println per.name is a baby, else classifier dot, not classifier, system.out.println per dot name plus is dead. No, is not a baby. There we go. So now what this does is, if it says is not a baby, so all this does is it checks if it's a baby, and if it is a baby, it'll say it is a baby. If it's not a baby, it says it's not a baby. If we remove this kill statement over here, it'll say that it is a baby because it is still alive. So okay, now we have a isBaby check. Let's try a more check which ties into the polymorphism which we talked about in the last video. Public Boolean is chicken, animal, animal. Now, polymorphism. If we pass an animal parameter into a method, it'll be an animal. It'll function as an animal. So how would we check if it's a chicken? Well, we would use something called instance of. Return animal instance of chicken. Now in Java, instance of is a check, which basically will check whether the parameter on the left is a subclass or equivalent to the class of the parameter on the right. So if animal over here is actually a chicken, it will return true for this. If animal over here is not a chicken, for example, if it's a flying animal or if it's just a regular animal, it'll return false because animal or flying animal are not subclasses of chicken. And if there were a subclass of chicken we made, say, I don't know, rooster, well, it would return true because rooster would be a subclass of chicken. Another important thing to note is that if animal is null, which means animal does not exist, this returns false. So this will check if it's a chicken. And just so that you see how that works, we will make animal per equals new chicken. Oops, chicken. Chicky. That's a good name. Don't judge me. Okay, so first of all, if classifier dot is chicken per system dot out dot println per dot name plus is a chicken. That's not as well as a chicken. Then else, oh my god, system dot out dot println per dot get name plus is not a chicken. We are not chickens. Now, well, one thing we can do to simplify this is just make string. String not equals empty string, and if classifier that is chicken, not equals empty string. Else, so if not classifier that is chicken, not equals not. And that way, all we have to do is system.out.println per plus is plus not plus chicken. Now, if we look at this little bit of code, not is an empty string. So if we skip this line of code, if we just assumed it didn't exist, it would just say per is a chicken. However, if the classifier returns false for is chicken, then not gets set to this string, not. So if we print this out, it'll say per is not a chicken. So let's see. Per is a chicken, right? See, it's chicken. So if we run this, oh yeah, okay, let me just set this to get name. So if we run this, Chicky is a chicken. And notice that there's like this weird like double space here. That's because of an empty string for not. We can actually probably make that better by just making this into a space and removing this preceding space. Okay. Right, no space. Okay, so now there, looks better syntactically. It says per is a chicken because not is an empty string right now. Now, if we make this into just new animal, now this is a different story. Chicky is not a chicken. Because animal is not a subclass of chicken, it's not a chicken. Now, walking animal has legs, right? We can do another check. We can check whether the animal is quadrupedal. Now, first thing we have to do is ensure that the animal is an instance of walking animal. Otherwise, the check means nothing because it doesn't have legs. We cannot cast it to a walking animal if it's not an instance of walking animal, right? So that's why we check whether it is walking animal. Otherwise, we return false. An animal that does not walk, that does not have legs, we're just pretending that an animal that does not walk does not have legs. So if it's not quadrupedal, if it doesn't have legs, and walking animal has legs. So now we've checked if animal is an instance of walking animal. How do you check whether something is quadrupedal? Well, quadr means four, pedal means legs. So actually a quadrupedal animal has 4 legs. What it needs to do is check whether the number of legs is exactly equal to 4. So we just have to do, well, first of all, return, we have to cast animal to a walking animal. Remember casting? Casting is when you change the type, change the class that a variable is treated as by using a little parentheses with the name of the class you want to be treated as. Since we cast animal to walking animal, well, first of all, we'll not get an error because we've already checked whether animal is a walking animal. And second of all, now we can access get num legs. Now we can't just do get num legs, like that's not a Boolean. You can't return an integer where you want a Boolean. And what we can't do is walking animal dot get num legs is equal to 4. Now you're thinking, wait, what? That doesn't make any sense. Why can't we check whether the two things are equal? Do you write is? How do you check the two things equal? Maybe dot equals 4? Well, no. I'm sorry, but that's not how it works. In Java, in order to check whether two things are exactly equal, you use something called the, equals operator. This is a variable assignment. Remember, you assign variables using an equal sign. However, to check whether two things are equal as a Boolean, you use a double equal sign. So a double equal sign is actually how you check whether two things are equal in Java. Now, the double equal sign is a bit limited. It only checks whether two things are exactly equal. It checks whether the numeric storage of two things are exactly equal. For objects, this doesn't quite work because two objects are only exactly equal if their numeric references are equal, which means two objects are only exactly equal using this operator if they are the exact same object. But we'll get into that later. Now, this will then check if an animal is quadrupedal. So let's make a new walking animal. Now, by default, walking animal is quadrupedal. See, 4. So classifier that is quadrupedal is not quadrupedal, it's quadrupedal. Okay, yeah. So now here, let me just save everything. Okay. Chicky is quadrupedal because Chicky has 4 legs. Notice how we go here. First of all, Chicky is an instance of walking animal. Chicky is an instance of walking animal, so we can do this. Walking animal, get num legs equals 4. Now let's say that Chicky is not an animal. He's not a walking animal, it's just an animal. Chicky is not quadrupedal because if we go here, if animal instance of walking animal, value is false. So this line of code is not run and we just get return false. However, if we make Chicky new walking animal Chicky and then to give it 5 legs, it also evaluates a false because when you run this line of code, well, Chicky is a walking animal, but this is not equal to this. Get num legs is not equal to 4 in this case because it's 5. Now, we can also check whether things are not equal using an exclamation mark and equal sign. So if I wanted to rename this to is not quadrupedal, which is a really weird thing to name your method. Oh, yeah, that's a saving issue. Okay. Well, we could actually check since this walking animal has 5 legs, this returns true. Chicky is quadrupedal. Is not quadrupedal. Chicky is not quadrupedal. But if we change this to 4 legs, because it checks whether it's not equal to 4, this will return false. So it will actually say Chicky is not quadrupedal. But anyway, we don't do checks like that. That's weird. But yeah, you just check if Chicky is quadrupedal. That was just an example of the not equal sign, which is surprisingly underused in my programs. But anyway, quadrupedality is just, it's a relatively simple check. You just check whether something is instance of something else and whether it has a certain number of legs. But actually, the funny thing about Java is that there is a special sign called and. Now, and functions in a specific way. It's exactly what you think it is. If this is true and, let me just delete some stuff here. And walking animal without getting on legs is equal to 4, then it'll return true. So if this check evaluates to true and this check evaluates to true, it will return true. However, if either of these is false, it will return false. So the AND operator works like this. Let's make Boolean A equals true. Boolean B equals false. Actually, I'm going to do this in the main method so that we don't have to like do some odd stuff. So let's just create a little Boolean A equals true. Boolean B equals false. System.out.println A and B. And B. So, okay, if A is true and B is false, A and B evaluates to false. If A is false and B is true, A and B still evaluates to false. If A is false and B is false, A and B still evaluates to false. But if A is true and B is true, A and B still it will evaluate to true. So AND is a special check which only returns a true if both Booleans on either side are true. Now A and B don't just have to be like Booleans, they can also be checks, they can also be numbers. So int A equals 1, int B equals 2, if A is less than 2 and B is greater than 1, it'll evaluate to true because A is less than 2, it's 1, and B is greater than 1 because it's 2. And of course, if we do A is greater than 2, which it is not, it'll evaluate to false because this condition is false and this condition is true, which evaluates to false. So AND only evaluates to true under one condition, which is if both of its sides are true. Now I'm going to change A back to Booleans because Booleans are easier to work with. As we talk about something called the OR. Now, the OR is represented using, it's a weird sign that you might not have used before. It's called a pipe. Up in the top right corner of your keyboard, if you look next to the if you look next to the backslash, this one, there is a little straight line. If you do shift and click that, it creates a pipe. A pipe is a vertical line and two pipes represent an OR. An OR is a check which only evaluates to false under one condition, which is that both A and B are false. It's not exactly the same as English OR. You don't say like, if I will have either an apple or an orange. That does not mean I will have an apple or an orange, but I might have apples and oranges. So an OR in Java is actually more equivalent to and/or in English. If you say, I will have an apple and/or an orange, or if you say, I will have an apple, an orange, or both. So that's what a Java OR is. Let's just look at it in action. If A is true and B is true, it should evaluate to true, as you see. If A is false and B is true, it should also evaluate to true. As you can see, if A is true and B is false, it should also evaluate to true, as you can see. And if A is false and B is false, then it should evaluate to false. The thing about ands and ors is that you can string as many of them together as you want. So you can have Boolean C equals false. And what this is basically doing is first it evaluates this or, then it evaluates this or. So whatever this condition is, it plugs it into this condition. So if all of these are false, it returns false. But if any one of them is true, it returns true. And if two of them are true, still returns true. Similarly for and, if two of these are true, it'll return false because one of them is still false. However, if all three of them are true, it returns true. So that is and or. Those are two of the fundamental gates of Java. They're called logic gates, and they're used in if statements in order to check certain conditions. Last one is not. Not A will basically just return the opposite of A, which is false. If I set A to false, it returns true. Not is a first level operator, which means that not A and B will actually return. So it won't do the same thing as A and B and then evaluate the not. It won't check whether A and B and then evaluate not. If it checked A and B and then evaluated not, since A is false and B is true, this would evaluate false and then it will return true. But it will not do that. It'll actually check if it'll actually invert A first. So false will be evaluated to true. And then it'll check whether B is also true, which is in this case true, so it'll return true. It'll have the same output, but it doesn't work exactly in that way. So let me just change this. Can I change it? So if not A, we'll evaluate first, so it'll be false. And B will evaluate next, which will be well, a false, and a true, which evaluates to a false. So not occurs before everything else. However, you can set a not to invert in its higher statement by doing this. Just a parentheses. A not is like PEMDAS. A not is equivalent to an exponent in PEMDAS, for example. An exponent only affects a single number, but it can affect multiple numbers if you put it outside of a parentheses. So a not operator just gives you the opposite of its condition, which is A and B, which is true because both of them are true, and it gets inverted to false. If I only put it on 1, well, first of all, I have to make this a condition which can actually function where differently. If I only put it on 1, and I set, if I only put it on 1, let's see, not A and B and C, this should evaluate to false, correct? Because not A is inverted. Then you check B, which is true, and C, which is true, but since an A is already false, it is false. An important thing to know about Java, as we can see if we go up to animal classifier over here, is that an AND statement is lazy. Same with an OR statement. If one side of the statement, if one side of an AND statement is true, if one side of the AND statement is false, if the left side of the AND statement is false, it won't do the right side. So if animal, for instance, was not a walking animal, it would just skip this side completely. You would not get a class cast error. You would not get a casting error from here because it would just skip the right side. If, however, animal is true, if not animal, if the left side of the AND statement is true, you would progress to this side, and since we've already verified that it's a walking animal, it will just check whether its number of legs is 4. So that's a useful thing about AND statements. Instead of doing like if animal instance of walking animal, check this, you'll just have to write if return animal instance of walking animal and number legs equals 4. So we can also try with using a while loop now. We've done if statements. If statements are basically just, a statement that runs each time, that runs only if a condition is true. However, a while loop runs as many times as the condition is true. Each time it runs, it'll check whether its condition is true, and if that is so, it will run again. So let's create a public void main loop. And let's make 3 animals. Animal 1 equals new chicken 1. Yes, you are named 1 now. No, stop it. Animal 2 equals new walking animal, just for kicks. 2, and animal 3 equals new, well, just a generic animal. Animal 3. Now these are 3 animals. And how about we make a little thing where each of the animals interacts. They do certain set of actions in each iteration of the loop. So let's do, well, first of all, we have to make a while loop. Now, a while loop runs as many times as a condition evaluates it true. Each time, a while loop is like an if statement, it just runs multiple times. When the program gets here, it'll go to the while and check, is this condition true? If so, it'll run this. Otherwise, it'll skip this. Once it runs this, it'll go back up here, check, is this condition true? If so, it runs this. Otherwise, it ends. Then it'll go back up here and check, and if it doesn't end, it'll go back up here and check if this is true. If so, it runs this, otherwise it ends. Another thing you can do to, in a while loop is use a condition. Similar to an if statement, you can do like, for example, if 1 equals 1, then run this. Since 1 equals 1 is just a condition, it just evaluates the true, it'll run forever. Now let's look at this in action. While true, system.out.println hi. What will happen? Let us see. And I'm just going to remove all this. Goodbye. Import classifier dot main loop. Let us run. What is happening here? Well, we are getting an endless stream of highs. If we go up to the classifier, while true is a forever loop. It will run forever because true always evaluates to true no matter what happens in the program. Conversely, while false will not return anything. In fact, it gives an error because while false can never evaluate to true. And the Java program is smart enough to actually just check this. It's just smart enough to say, wait, this program is never going to evaluate the true. We can't run this. So, in fact, we cannot do while false. Now, let's make these animals interact. Let's make a little program where 3 animals interact. When does this program end? Well, when all the animals are dead. So how do you check what animals are dead? Is dead. When 1.is dead, and 2.is dead, and 3.is dead, this program should end. Well, while loop only runs as long as the condition is true. So actually this condition, we need to invert it. While not 1.is dead, and 2.is dead, and 3.is dead, it'll check, is 1 dead, is 2 dead, is 3 dead, and if all these are false, it will run. Basically, it'll run as long as all 3 of them are alive. The instant all 3 are dead, it'll stop running. Now, what should the animals do? Well, they can live. Let's make them live. Yes, animal, live, live. Now, if we just stop here, we are going to have a really long program. Remember, animals live for 50,000 instants. So they will live for 50,000 instants until they finally age past the age that they can survive at, which is 50,000. So now, at this point, all three of them have died. All right, that's all well and good. Now, another fun thing you can do with Java is called random. So what random is, it's just an object. If you press Control-Shift-O, it'll automatically import the necessary object. A random, like a random as an object, just generates random numbers or random Booleans or random primitive data values in general. So int choice equals random.next int. Now, what choices do we have? What can animals do? Well, they can eat, they can die, and they can move. So 3 choices, random.next int, 3. Now, funny thing about random.next int, it's an inclusive exclusive function. So by default, its lower bound is 0, and by default, its upper bound is excluded. So random.next int will generate a random number, which is either 0, 1, or 2. 3 is excluded, and 0 is the minimum. So we have 3 choices, 0, 1, or 2. Now we can use if statements. If choice equals 0, well, first of all, we need to actually select an animal to do this action on. Animal main equals null. Null means no object. An object, a variable set to null will have nothing in it. So if choice equals 0, then main equals 1. Else if choice equals 1, main equals 2. Else if, well, we don't even need to do that. We can just do else main equals 3 because we know for a fact that the variable choice will only be 0, 1, or 2. So if it's not 0 and it's not 1, it can only be 3. So in this case, else if is actually a funny statement in that what it does is it's like else, but with a second condition. If this condition is true, it runs this and skips all of this. If this condition is true, if this condition is false, it'll run this, and then if this is true, they'll skip all this. However, if both of these are false, it will just run this. And since both of these must be false for this to be true, it will run this if all these are false. So that is an else if. Else ifs are really useful. Programmers use them all the time. And now we have 3 instances. First, what this does, let's recap that, is that first of all, it makes them all live. Second of all, it chooses a random number, and then it sets this variable, animal main, to either 1, 2, or 3, depending on what the number is. Now we can just use, well, main.eat, let's say, because when we use main.blank, it will run it on whichever animal is chosen. Now we have to do a second choice. So let's just reuse the variable choice and do random.next int. Each time you call this, it will rerun the function. The random.next int will produce a new random number. So you don't have to worry about it like producing the same random number or anything like that. It'll run a new random number. Now, if choice equals 0, once again, we are going to do an if statement like this. However, this time we're going to do if choice equals 0, main.eat, and we'll just give it 100 food points. Else if choice equals 1, main.kill, and yeah, the animal will die. And else, we can just do main.move. Now, there is a 1 in 3 chance that the animal will die each iteration. And there's a 1 in 3 chance for each animal to be chosen because we have used the random. So let us run. All right, let's see. 1 is living, 2 is living, and 3 is living. 2 moved to 4, 0. All right, so we have our first random choice. 2 did something. Now, 1 moved to 1, 0. Second random choice. 1 did something. And 1 has eaten food. So third random choice, 1 ate food. 3 is now dead. 3 was killed. That is our random choice. And as you notice, 3 is dead persists for the rest of this. So now 1 moved to 2, 0, 1 moved to 3, 0. Okay, 1 is moving, that's nice. 3 is still dead. 3 has been killed again. Okay, so that's funny. Because 3 is already dead, but we call the kill method regardless of whether it's dead, it gets killed twice. You are doubly dead, 3. 2 is dead, and 1 is dead. Now that all 3 of them animals are dead, well, the program ends. Now, back to the kill method. Let's make a nested if statement. If choice equals 1 and 3 is already dead, we don't do anything. So if main.is dead, if not main.is dead, main.kill, else, well, nothing. We don't have to do anything else. So yeah, here we check if main is dead, and then we kill it. But if it's dead, it won't kill it. So now we just have to look through this, and 3 is dead, 3 is dead, and if we go to this, since 3 is dead, well, it won't die twice now. So yeah, that is if statements. As a recap, there are if statements are Booleans. If an if statement is Boolean condition evaluates to true, it'll run. Otherwise, it'll either skip down to the else block or it won't run at all. Now, for a while loop runs as long as the condition is true. Once its condition is false, it'll end the loop immediately. But otherwise, it'll keep on repeating as long as its condition is true. Booleans can be any kind of condition. It can be greater than, it can be less than, it can be the doubles equals sign, and it can also have ands, ors, and nots. A not statement just inverts a condition, an and statement just checks whether both sides are true, and an or statement checks whether one of its sides is true, at least one. So this was the beginning of if statements and Booleans. Next thing on our list is going to be, most likely, is going to be, sorry, it's probably going to be strings, or we might do errors. It's still a bit up in the air with the system, but I hope you learned something, and see you on the next tutorial.